Alrighty guys, so this is part 2 of topic 1.4. I have it as module 1.4.2. It's just part 2 of the supply and demand model. So the last topic, part 1, kind of just got you acquainted with the components of the model, supply, demand, and the idea that when you put them together you get an equilibrium. What happens, what does equilibrium mean? What happens when a market is out of equilibrium? We talked about shortages and surpluses. So now what we're going to do is we're really going to use that model and we're going to show how an event can change the equilibrium price of a good. So we are still in chapter 3. So a little bit of a recap from last time. We talked about how the price of a good is determined when we put supply and demand together. We talked about the difference between demand and quantity demanded and supply and quantity supplied. So those little quantity demanded and quantity supplied, we say they refer to a single amount along a demand or a supply curve. They change when the price of a good changes, and we show that as a movement from one point to another along a demand or supply curve. And demand and supply, that is the big picture, the relationship between all the prices and all the quantities demanded or supplied. And that we show by shifting the entire curve to the left as a decrease or to the right as an increase. And those shift in response to non-price changes. So those non-price changes we talked about, when I change something besides the price of a good, that's what this topic is referring to. So we've got 3 key questions: what shifts demand, what shifts supply, and how do supply and demand shifts affect a market? So we're going to start by talking about these factors. There are 6 for each of them, 6 factors that can shift a demand curve, 6 factors that can shift a supply curve. I'm going to move through them fairly quickly. I'm going to give you some examples just to make sure we're solid on it. But for the most part, I want to get to some practice questions at the end so you can get a feel for actually using these topics. And you can always go back in the concept guide and reference these definitions and examples. So here's a quick list of everything that can shift a demand curve. So these are things that affect the entire relationship between price and quantity demanded for a market of buyers. So when I change something besides the price, I violated the ceteris paribus assumption. So remember, ceteris paribus means all else equal. And so if I change something besides the price, ceteris paribus doesn't hold anymore. So I have to change things. I have to draw a whole new demand curve, either to the right of the original or to the left of the original. So those 6 things that shift an entire demand curve are listed right here. Changes in income, the price of a related good, changes in taste or preferences, future expectations of prices, and changes in the population of buyers. I have this 6th one, taxes. The reason it's starred here is because it's not in your textbook. However, it is one of those factors that can shift a demand curve, and it's been in previous economics textbooks, so I want you to know that factor as well. There's probably far more things that could shift demand for a product, but most events that we can think of fit into one of these 6 categories in one way or another. So when I talk about a shifting demand curve, I want to give you an example of what that looks like. So here I have the demand curve for cantaloupes, represented by the demand curve D1. It's downward sloping, showing our law of demand. We can see there is an inverse relationship between price and quantity demanded. I've just marked 1 point on the demand curve here. When the price is $5, the quantity demanded of cantaloupes is 6. And so here's an example of an event that could shift the demand curve to the left. We call this a decrease in demand. So when the whole line moves to the left of the original, like at D2 here, that is a decrease in demand. So here's an example of that. A health warning causes buyers to demand fewer cantaloupes. So for example, maybe some health warning comes out that the cantaloupes have become contaminated in some way. That means that all the same set of prices as before, people are just going to want to buy less cantaloupes. It changes all of the corresponding prices and quantities demanded. So we move it to the left of the original. You might notice too that it's a little bit lower on the graph, so you might want to think a decrease is downwards. Try to avoid that. Think that a decrease is a shift to the left of the original, and then it'll stay consistent when we move on to supply. An increase in demand is picking up the whole line and moving it to the right of the original. So here's an example of an event that would do that. A medical study reports that eating cantaloupe lowers cholesterol, and this causes buyers to demand more cantaloupe. So if this new medical study comes out, says cantaloupe is good for you, it lowers your cholesterol, it means suddenly at all the same prices as before, all of the quantities demanded are just going to be higher. So we got to move that demand curve out to the right where we see D3 here. So all 6 of these factors on the last slide, those are what can shift either the demand curve to the left or the demand curve to the right. So in both of these cases, option number 3, changes in taste or preferences, is what we're triggering here, right? When those medical studies come out saying cantaloupe is dangerous or cantaloupe is good for you, that's going to change people's tastes and preferences for more or less cantaloupe. So that's just one example, but we'll talk about the other 5 real quick. So the first option on that list was a change in income. So income is the amount of money that you earn, typically in the consumer's wages. So when we talk about how income affects our demand for a good, we want to distinguish between a normal good and an inferior good. So make sure to write down somewhere, or if you have your concept guide handy, highlight most things that we buy are normal goods. In fact, I will always tell you in a question if a good is inferior. If I don't say specifically that a good is an inferior good, you can pretty much assume it's a normal good. So a normal good is goods that we buy more of when we have more income, and therefore we buy less of them when we have less income. So think shopping at your favorite clothing store. Maybe it's Urban Outfitters, maybe it's somewhere else. Think your favorite restaurant and all that good stuff. Those are normal goods. If you were to get a raise at work, you'd probably buy more of that stuff. If you were to get fired from your job, you'd probably buy less of that stuff. Okay, the opposite of a normal good is an inferior good, and these are funky. We actually buy more of the inferior goods when we're broke, and we buy less of them when we have more money. So think about the same scenario before. If we're thinking about demand for something like ramen noodles, if you were to get a raise at work, you would probably buy less ramen noodles than before and instead go out and go eat at your favorite restaurant more. Vice versa, if you get fired from your job, you're going to buy more ramen noodles because you don't have as much money and ramen is fairly cheap. So inferior goods, they have the opposite relationship to income, or demand for inferior goods has the opposite relationship to income as normal goods do. They're kind of counterintuitive. So inferior goods are pretty rare. So ramen is the best example, but another example would be like generic brands versus name brands, public transportation, canned goods. Those tend to be inferior. But like I said, I'll always tell you in a question whether or not a good is inferior or not. Okay. The second factor that can shift demand is the change in the price of a related good. Now, you might be looking at this and seeing that word price in the title and thinking, hold on a second, in the last lesson video, I repeated over and over again that the change in the price does not change demand, doesn't shift the curve, it changes quantity demanded. And that's correct. But I'm not talking about the change of one particular good whose demand we're discussing. I'm talking about the price of something else connected to it. So I can shift the demand curve for an item, not if I change its price, but if I change the price of its substitute or its complement. So substitutes are goods that can be used in place of one another. So think oven pizza versus delivery pizza. So I'm going to jump over here real quick to my sketch pad. And just to give you an example here, if I were to draw a demand curve, let's see, this is my price axis, this is my quantity axis. We'll call this a demand curve, call this D1. Let's say this is the demand curve for oven pizza. Okay, if I change the price of oven pizza, it's not going to shift the demand curve. It's just going to cause a movement along the curve. If I shift the price of oven pizza's substitute, let's say the price of delivery pizza, so this is the price of its substitute, that can shift demand. So let's think about this. If delivery pizza gets more expensive, so the price of delivery goes up, I'm going to buy less delivery pizza now. The law of demand tells us that when the price of delivery pizza goes up, my quantity demanded of delivery pizza goes down. So what that means is even if the price of oven pizza doesn't change, we're just going to have greater demand for oven pizza because I'm buying less of its substitute, and vice versa. If the price of delivery were to fall, so if the price of delivery pizza decreased, it's a down arrow, that means I'm going to buy all this cheap delivery and I'll have lower demand for oven pizza. Even if the price doesn't change at all, I'm just buying less oven pizza because I'm already buying all the cheap delivery. So that's true of most substitutes. When a substitute becomes more expensive, we buy more of the alternative. When a substitute becomes cheaper, we buy less of the alternative. Complements are a bit different. So complements are two goods used together, like hot dogs and hot dog buns, milk and cereal, if you're from the South like me, biscuits and gravy, things that you like to consume together. So when you think about the price of one, you naturally kind of put it together with the price of the other. So this kind of has the opposite relationship here. So if we are thinking about the market for two complements, let's say cereal. Here's my demand curve for cereal. Now, changing the price of cereal will not change the demand curve, but changing the price of its complement, let's say milk, that will shift demand for cereal. So if the price of milk increases, I know that my quantity demanded for milk will fall. I'm going to buy less milk because milk is more expensive. Now, it doesn't matter if the price of cereal changes, demand's just going to be lower. It's going to shift to the left. And the reason is I'm already buying less milk, so I don't need as much cereal to go with it. Vice versa, if milk is on sale and the price is low, my quantity demanded of milk will increase. So I'm going to buy a lot more milk, and that means I need more cereal to go with it. So even if the price of cereal doesn't change, demand is just going to be higher here. So that's a relationship for complements. And again, we'll do some more examples with these at the end. All right. So here's another good example distinguishing between a change in the change in quantity demanded versus a change in demand. So here I have two markets, two price and quantity axes, and on the left here I have the market for peanut butter, and I have on the right the market for jelly. Now I can show the same event, the price of peanut butter increasing in these two different graphs. So just looking at the left side here, if I'm thinking about the market for peanut butter, if I change the price of peanut butter increases, the result will be a movement along the demand curve. And we would say quantity demanded of peanut butter decreases. So just like this example here, we'd move up and to the left along the demand curve to that higher price from $3 to $4, and the result would be a lower quantity demanded from 4 to 2. Okay? If I take the same event and I think about it in terms of the market for jelly, we need to think about how peanut butter and jelly are connected. They are related goods. And peanut butter and jelly are complements because you can put them together and make a yummy sandwich. So we want to think about how demand for jelly changes when I change the price of its complement, peanut butter. Now, I'm not changing the price of jelly, so it's not going to be a movement along the curve. I'm changing the price of its complement, peanut butter. So in the case of jelly, this would lead to a shift in demand. So because peanut butter is more expensive, I'm going to buy less jelly. That's going to shift jelly's demand curve to the left. So this is a really good example, a difference in the change in quantity demanded versus a change in demand. It's a really common mistake my students make. In both cases, I buy less of both, but we just show them differently in the graph, and we use different words to describe them. So over here in the peanut butter market, when I increase the price of peanut butter's quantity demanded falls. Here in the market for jelly, When the price of peanut butter increases, jelly's demand falls. So make sure you keep those differences straight. All right, the third thing that can shift a demand curve are changes in tastes and preferences. So this could include fashion trends. So if you are very into fashion, you know things go in and out of style all the time. That would result in increasing and decreasing demand for something. But it doesn't have to be related to popularity or even fashion or trends. It could be like the examples discussed with the cantaloupes in the beginning, right? People can just have preferences for more thing because they anticipate a need or they think something is dangerous or popular or whatever it is. Advertising tries to capitalize on this change. Advertising for a product to try and increase demand for a particular brand. So this is a really, really common demand shift here. All right, 4, 5, and 6 are pretty interesting. So future price expectations. So this is how the demand curve today can depend on what I think the price might be tomorrow. So a good example of this would be thinking about gas prices. This is my favorite example to talk about. So let's imagine, hypothetically, that you're not in quarantine and you are driving around and you are thinking about filling up your tank with gas. So here is your demand curve for gas. Okay, we'll call this D1. And as you're driving around, you're at that point where you're headed home from work and you could stop and fill up the tank, or you could wait until tomorrow. And you hear this news report on the radio that says, tonight at midnight, gas prices are going to double. So tonight at midnight, gas prices are going to go up. What do you do as a consumer? Well, you probably go ahead and fill up the tank today. You increase your demand for gas. And the reason is because you think something's going to be more expensive tomorrow. So if you anticipate the future price to be higher in the future, you go ahead and increase your demand today. Shift that demand curve to the right. Vice versa, if you're driving around in your car, you could stop, you could wait, and you hear a news report that tonight at midnight that gas prices are going to drop, they're going to be cut in half, you're going to go ahead and wait it out and fill up the tank tomorrow. So you're going to decrease your demand today if you think gas prices will be lower in the future. So this is how your demand curve in the present shifts about what you think the future price will be. And the interesting about future price expectations is it doesn't actually matter if your prediction was right or wrong, right? No matter which one of these news reports you heard over here that shifted demand, if you wake up the next day and the news report was dead wrong, gas prices didn't double, they weren't cut in half, they just stayed exactly the same, it doesn't matter. You already had shifted your demand based off of this expectation. So that's a pretty powerful one as well. Changes in the population of buyers. So really good examples of this would be right now with a lot of the stay-home orders or lots of orders limiting the amount of people who can gather in a restaurant or in a public space. Basically, the more people who are allowed in an area or the population grows in an area, that's going to be more demand for a product. And if the population of buyers decreases, either because there is a population decrease or because maybe you're only allowed a certain amount of people in a restaurant at a time, if the population of buyers decreases, that's going to be less demand. Okay. The last one are taxes. Specifically, this is a type of tax called an excise tax, which just means a tax on a particular item. So for example, a cigarette tax or an alcohol tax that a lot of states have. So if it's a tax for a particular item that a buyer has to pay, so there's the price tag at the grocery store, then you take that item up to the register, and then on the receipt they have that little extra tax added on that you have to pay. Not quite the same as sales tax. This has to be specific to an item, like a special cigarette tax or a special alcohol tax. That's going to shift demand as well. If we increase excise taxes, that's going to mean less demand because as buyers, we don't like to pay them. And if we lower or get rid of excise taxes, that's going to increase demand for that product. So those are the 6 factors for demand. So right here, I just have a summary of those 6 factors talking about them in the direction that can shift demand to the left. So these are possible decreases in demand. So if your income were to fall for a normal good, if your income rises, and we're talking about demand for an inferior good like ramen noodles, if a substitute becomes cheaper, or a complement becomes more expensive, tastes shift to less popularity, the price is expected to drop in the future, so I wait it out today, like with the gas prices. There are less buyers, or taxes are created or raised. So we have a new tax that we don't like to pay as consumers, or we increase an existing tax that would decrease demand. If I flip those, I get increases in demand. So income rises, income falls for inferior goods, substitutes rises, all of that stuff, all the same 6 factors. I'm just talking about them moving in the opposite direction. So if you want to hit pause here, this is a good little video that kind of illustrates the difference between a change in quantity demanded and a change in demand for hula hoops. So if you pause this video, give it a watch on the supplemental video tutorials for topic 1.4.2, and then next to it you should have an explanation video that shows that graphically. Look out for the change in quantity demanded, which is caused when the price of the hula hoops change, versus the change in demand, which is when people's tastes and preferences of the children in the video shift the whole demand curve. All right, moving right along to supply. Just like with demand, there are 6 factors that can shift a supply curve. Now again, with supply, try to think like a seller. Most factors that shift a supply curve have to do with sellers' bottom line, their profit. So if sellers are profit motivated, these are going to be the 6 things that shift their supply curve. The cost of inputs, so that's the stuff they have to buy to produce the good or service that they're trying to sell. Technology, government policies, taxes, subsidies, and we're also going to talk about regulations. 4 and 5, again, they're starred because they're not in your book, but they are analogous to some of the ones we discussed with demand. Sellers also anticipate future prices, and the population of sellers matters. And then 6 is natural conditions. All right, so here is an example of a supply curve for the market of cups of coffee. So I've got this upward sloping supply curve that represents the law of supply. When the price per cup of coffee is higher, sellers want to sell more. When the price of cups of coffee is lower, sellers want to sell less. I've got this starting point marked off just as an example. And so here is an example of a decrease in supply. So a decrease in supply, still a movement to the left of the original. So this would be an example of a hurricane that destroys Colombian coffee crop causes sellers to produce less coffee. So that's an example of those natural conditions. Sellers are going to sell less coffee because we've just decreased the supply. Shift that curve to the left. Increases in supply are shown as shifts to the right. So an example of that would be a new way to brew a richer coffee at half the cost causes sellers to produce more coffee. So that's one of those technology changes that were mentioned on the last slide. All right, so talking through those factors, first, the cost of inputs. So inputs are resources used in the production process. So think about those resources from 1.1 economic foundations, land, labor, and capital. Typically, the more expensive those resources are, the less profitable for my sellers, right? So if the cost of labor goes up, if the cost of their natural resources go up, if the cost of capital goes up, they're all going to decrease their supply. And vice versa, if the cost of those resources goes down, that means more profit for my sellers. They can make this item more cheaply and keep more money in their pockets at the end of the day when it comes to profit, and that'll cause them to increase supply. Changes in technology. When technology advances, it typically allows sellers, again, to produce a product for cheaper. So technology advancement increased supply. If there's a decline in technology, that would decrease the supply. Declines in technology are pretty rare, but they could happen, theoretically. Third, government policies. There are 3 different versions here. First, taxes. So just like consumers, sellers don't like paying excise taxes either. However, most of the time, the sellers do pay excise taxes if they are in place. So taxes are going to decrease supply. If we were to remove or lower taxes, that would increase supply. Sellers would want to sell more. A subsidy is the opposite of a tax. This is like a grant from the government to encourage production. So this is a use of tax dollars. So here in the United States, we give a lot of money to farmers. We give out farming subsidies. So the more subsidies that a producer were to get, they would increase their supply. If we were to cut subsidies or get rid of subsidies, they would decrease the supply of that item. And last are regulations. So regulations are just rules. We talked about that again in that first topic, 1.1, economic foundations, the rules of the game. And the reality for most firms or suppliers in the market is that complying with regulations typically mean that a firm has to spend money. So things like a worker safety regulation, if I were to pass a rule saying, hey, factory owners, you need to buy goggles for all your workers or put down these non-slip mats, that's going to be expensive for the seller. So the more regulations there are, they tend to decrease their supply because it means their business is less profitable. And the lower regulations there are, the more sellers increase supply because it's not as expensive for them to produce now. And that's true of worker safety regulations, environmental regulations, research-based regulations, consumer protection and safety. All of those regulations are going to affect sellers and their willingness to supply. Fourth, future expectations. So a seller would react the opposite of a buyer here. So if we think back to our gasoline example here, and instead of you driving around in your car thinking about the consumer side of gas, let's think about the seller side. If you were to have a gas station and if you heard on the radio that tonight at midnight gas prices were going to double, you might close up shop early and try to sell all your gas tomorrow for that higher price. And vice versa, if you heard gas prices were going to fall tonight at midnight, you might stay open a few extra hours, try to sell off what you can before that price drop happens. And fifth, population of sellers. If new businesses were to open up, remember we talk about market supply and market demand. So the more sellers there are, the more there is supplied. The less sellers there are, the less the supply is. And lastly is natural conditions. So this especially applies to agricultural industries, so like farming. Good weather means better supply, bad weather means less supply, but it can expand beyond agriculture as well. So lots of times here in Florida we have hurricanes that can cause destruction and reduce supply of a lot of products that aren't just agricultural based, but also businesses and things like that. All right, so again, here's a summary of those 6 factors. This is everything that could decrease a supply curve. So increasing costs of resources, declines in technology, new or higher taxes, cutting subsidies or withholding subsidies, regulations that increase the cost of production. The price is expected to rise in the future, so you want to reduce your supply today, wait, try to sell it for that higher price later. A decrease in the population of sellers or bad natural conditions, like a natural disaster. And then increases in supply are all those same factors but shifted to the right. And again, these are all in your concept guide and the PDF PowerPoint notes. All right, so now we are going to basically go through some examples of how we take an event and figure out how that affects the market for a product, affects the equilibrium when there's a shift in supply and demand. So I have these 4 factors or these 4 steps that you can follow to solve any supply and demand question. So if this were a face-to-face class, and in many economics classes, your professors might want you to draw and sketch graphs. I will show you how to do that with a couple examples, but luckily all of your tests are open note in my class, so you can use the concept guide to kind of figure out the end result on equilibrium. But we're still going to roughly follow these 4 steps. So I'll show you how to solve it both ways, with the graphs and without the graphs if you really don't like graphs. So step 1 is going to be think about an initial equilibrium. So if you're drawing it, draw a supply and demand model before the economic change took place. So you just draw a graph in equilibrium. Step 2 is going to be the hardest one. So step 2 is actually reading the question and figuring out if the event that is described in the question is one of those 6 factors that's going to shift a demand curve that we just went over, or one of the 6 factors that'll shift a supply curve. Based on that, you'll move on to step 3, figure out, okay, so I've decided if this is a supply or demand shift, and then you need to decide, is this an increase or a decrease? If you're sketching it out, we draw increases to the right of the original, decreases to the left, and then we identify the new equilibrium price and quantity and compare that to the original. So you can follow these 4 steps anytime you have a supply and demand question, so we'll do a couple examples here. So here we go. Using the 4-step approach, how would excellent weather conditions during the summer affect the quantity and price of salmon? So step 1 is just to draw your initial graph in equilibrium. So this is how I like to label them. Have a price and quantity axis here. Go ahead and label along that bottom axis what good we're talking about. Here it's pounds of salmon per month. I've got my upward sloping supply curve labeled with an S, my downward sloping demand curve labeled with a D, their intersection point, that's my equilibrium, and I've marked out the equilibrium price P1 and the equilibrium quantity Q1. So this is my starting point. So now step 2 is to think about the event. So I have excellent weather conditions. So excellent weather conditions, is that one of the 6 factors that will shift a demand curve, or will it shift the supply curve in the market for salmon? So think about that for a second. All right, so hopefully you read this question and you thought that this was an example of natural conditions, which is a factor that will shift supply. Okay, so that upward sloping supply curve we have here, this is what's going to move. And supply, because I have excellent weather conditions, that is going to increase the supply curve, shift it to the right. So if you go back to your sketch, we're going to draw my new supply curve for step 3. There it is, to the right of the original. And now I'm going to mark my new intersection point here. I'm going to call that E2. And then we're going to figure out what happens to my equilibrium price and quantity. So P2 is lower than P1, so my equilibrium price decreased. And Q2 is greater than Q1. Remember, as you move out to the right along this axis, the numbers get bigger. So we'll say the equilibrium quantity here increased. And that's essentially how you complete it. So the answer on a test here would be that the equilibrium price fell and the equilibrium quantity increased. So I'm going to do a couple more examples here on my sketch pad, following my 4 steps. So here, zoom in a teeny bit, move this way. So this question says, consider the market for hot dog buns. What will happen in the market for hot dog buns if the price of hot dogs decreases? So you might already be jumping and starting to think about the answer here. Let's just take a pause here and do step 1. You can actually do step 1 before you even read the question. Just draw the market in equilibrium. So I'm going to draw out these axes. I'm going to label this price and this quantity. And I want to write out next to quantity what market the question is asking me about. So here this says consider the market for hot dog buns. So that's going to be really important here. I'm not asking you what happens to hot dogs. I'm asking you specifically what happens to the market for buns. So I'm going to write hot dog buns. So I'm talking about the buns here. I'm going to draw my downward sloping demand curve. We'll label this guy D1. I'm going to draw my upward sloping supply curve. Label this guy S1. Here's my equilibrium point. That's going to be E1. And I'll call this guy Q1. And this guy P1. So there's step 1. Step 2 is to read the question and figure out if this is supply and demand in which direction. So what will happen in the market for hot dog buns if the price of hot dogs decreases? So I've got the price of hot dogs decreasing. So let's think about it. Hot dogs and hot dog buns, how are they related? Hopefully you remember from the example slides that these two are complements. So when I change the price of a complement, that's going to shift the demand curve. So this downward sloping line is going to be the one that moves this time. Okay, so that's one of the 6 factors that can shift demand. And so my complement, hot dogs, are becoming cheaper, right? So I'm going to want to buy more buns to go with those hot dogs. So my demand for buns is going to increase. I'm going to draw that new demand curve, D2, out to the right. I'll mark my new equilibrium point here, E2. Mark my new quantity, Q2. And my new equilibrium price, P2. So, as a result of this event, my equilibrium price will increase and my equilibrium quantity will also increase. So, kind of a strange turn of events, but if hot dogs get cheaper, it might mean hot dog buns get more expensive because people need more to go with it. All right. Now, if you didn't like that graph, this is page 5 of your concept guide. You can just use this nifty table here to figure out what happens to the equilibrium price and quantity. So personally, I like to sketch things out and not memorize things, but here I know once I figure out that demand for buns is going to increase because hot dogs are cheaper, the result on my equilibrium price and quantity, they both increase here. So you don't even have to sketch it out and find the new equilibrium if you don't want to, since your tests are open note. All right, so another question, consider the market for airline tickets. What will happen in the market for airline tickets if pilots' wages decrease? Okay, so maybe we will start with the table on this one. So, determine which side of the market is being affected, demand or supply. So, who is going to care more in the market for airline tickets about pilot wages? The buyers of airline tickets or the sellers of airline tickets? Now, the tricky thing that a lot of my students do here is they try to turn everything into a demand shift because they're used to thinking from the perspective of a consumer. And so I get lots of people here who try to rationalize how a decrease in pilot wages would affect demand for airline tickets. But in reality, if you are finding yourself making multiple jumps, like that the pilots quit all their jobs and that, they start going on strike and airline tickets get more expensive and blah, 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 you're overthinking the question. We want to just take the event itself, pilot wages decrease, and try to fit it into one of those supply or demand factors that we talked about earlier. There can be a million reasons why pilot wages decrease. There can be a million effects on the pilot labor market as a result. So we're not going to imply in extra events. So just ceteris paribus, pilots' wages decrease. Who cares about that more, buyers or sellers? And it's going to be the sellers. And what we're shifting here is the cost of an input, specifically labor. If I am a supplier of airline tickets, I need to hire pilots. Suddenly, if I can pay those pilots a little bit less, what happens to my profit? It's going to go up. So lower pilot wages means more airline tickets sold. So we're going to say this results in a supply increase here. And when the supply of airline tickets increases, it's going to cause the equilibrium price to decrease and the equilibrium quantity to increase. Now, if you wanted to sketch that out in graph form, we can do that. Step 1 is draw my initial equilibrium. So we've got price, quantity. This question says consider the market for airline tickets. Airline tickets. Remember, I'm not asking you about the market for pilots here, just airline tickets. I've got demand for airline tickets. I've got supply of airline tickets. Those are Delta, American, all those folks. I've got the intersection here, E1. I've got Q1 and P1. Okay, so if pilots' wages decrease, my supply is going to increase or shift to the right, We always draw increases as a shift of the whole curve to the right of the original, so we'll label this guy S2. There's my new equilibrium, we'll call him E2. And then the corresponding result is going to be lower price and Q2, higher quantity. And that makes sense, right? If pilots don't have to be paid as much, airline tickets will be cheaper and people will buy more of them. So hopefully that makes some sense. So what I have here are just some summaries of the 4 possible outcomes that you can have when you are given a supply and demand event and a shift in equilibrium. So the 2 examples we just talked about were demand increases with the hot dog buns and a supply increase with the airline tickets. The result of those will always be the same. For a demand increase, price and quantity both go up. And for a supply increase, price falls and quantity increases. Vice versa, if these curves were to shift to the left, if we had a demand decrease, so maybe items shifted to less popularity, or there was a lower population of buyers, or the price of a complement increased instead of decreased, that would decrease the demand curve shifted to the left. The result will always be a lower equilibrium price and quantity. And for a supply curve, a shift to the left is going to mean higher prices and lower equilibrium quantity. Always, always. And that's also in your concept guide here, just summarized in table if the graphs are throwing you off. All right, so now we're going to add a little bit more of a layer of complexity to these problems. I want you to be able to evaluate what would happen if I gave you 2 events at the same time. So we've been looking at those 3 examples now that we've done together, ceteris paribus, all else equal, right? But in real life, events don't happen one at a time. Sometimes multiple changes occur in a market that cause prices and quantities to shift. So I want you to be able to solve at least 2 events at a time. And so when I give you a question with 2 events at a time, one of the events will always shift a supply curve, and one of the events will always shift a demand curve. So you can memorize those 6 items for supply and those 6 for demand, or you can kind of summarize and try to rationalize your way through them by thinking that supply shifts generally have to change production costs for my sellers. And the higher production costs, the less the supply. And the lower the production costs, the more the supply, because it all comes down to profit for those suppliers. Demand shifts typically have to do with consumers. That changes their willingness to pay for a good, whether it's the price of a complement, their income, their tastes and preferences, all that good stuff. So now I have 2 events at the same time back in our salmon market. So consider the market for salmon, and 2 things happen simultaneously. First, a major drought hits the Northwest United States, and 2, a medical journal reports that people who consume salmon live longer than people who eat other fish. Now we're going to follow those same 4 steps that we discussed earlier. However, we're just going to change the way we sketch out my new equilibrium on the graph a little bit differently if you are using graphs. If you're using a table, no biggie, you can still use the concept guide on that test. So basically, we're just going to do step 2, read the question, figure out what's shifting and in what direction on its own. So if we look at this first event, a major drought hits the Northwest United States. That's going to be a supply shift because we're talking about a natural condition, and it's going to decrease supply, shift it to the left. The second event, a medical journal reports that people who consume salmon live longer than people who eat other fish. That is going to be a demand shift. You can figure that out through process of elimination because we already figured out the first one was supply. Or you might recognize that this is a change in people's taste and preferences. This is going to make demand higher because this is an increase in popularity because of these health benefits. So on its own, the first event will decrease supply and the second event will increase demand. So if you go back to your concept guide here, we have a demand increase, which is going to cause price and quantity to both increase. And then I have a supply decrease, which causes price to increase and and quantity to decrease. So I just have that written here on this slide. By itself, the decrease in supply leads to a higher price and a lower equilibrium quantity. That's because of the drought. And by itself, the increase in demand because of that medical journal report is going to lead to a higher price and a higher quantity. So when we put these two events together, both of them lead to a higher equilibrium price, so the combined effect will certainly be a higher price. But these two are fighting against each other. The first event leads to a lower quantity, and the second event leads to a higher quantity. So we would say the equilibrium quantity is unknown, or we use this fancy word called ambiguous. Ambiguous just means it could go either way. So when I give you two events at a time, there will always be something, either the equilibrium price or the equilibrium quantity. One of them will be ambiguous here. So if you scroll down through the concept guide, I got some examples here, the single shifts. There are kind of our tables. So here I have supply decreasing and demand increasing. That leads to that increase in price and an ambiguous change in quantity, which is exactly what I showed here. So if we were to sketch out the change, the only difference in the way we sketch the graph is we know that that drought is going to cause the supply curve to shift to the left, but we don't quite know how far to the left, so I like to just draw a few possibilities. So here I've got 4 dotted lines as supply curves to the left of the original. You don't have to draw that many. I normally just draw 2, but the more the merrier. They're all moving to the left of S1 because I know supply is decreasing. I just don't know by how much because of that drought. Then we're going to do the same for demand. We know that medical journal means demand increases, so the demand curve is going to shift to the right, but we don't know how far to the right, so we'll draw a few different possibilities here, all of them out to the right as dashed lines. Now, if you draw those two on the same graph, you're going to get this area of overlap between the supply and demand curves. If you think about the original graph as dividing into 4 different triangles, a top triangle, a bottom triangle, a left triangle, and a right triangle, you can see everything's overlapping in this top triangle of the graph. And so what this means is these are new potential equilibriums for us. So essentially, anywhere in this purple triangle is fair game. And so if we think about any point where our new equilibrium could be in this triangle compared to E1, we know all of the prices in the purple region are going to be higher in terms of price than they are at E1 because they're all above this initial $10 point at E1. So that's how I know for sure my price is going to be higher. Now the quantities compared to E1, here my equilibrium quantity was initially 500 pounds of salmon. That is ambiguous because if I have an equilibrium on this side of the graph, that's lower than 500. If I have a point on this side of the graph, on the right side, that's going to be higher than 500. So if you think about this triangle, all the prices are definitively higher, but the quantities could go either way. That's why we say the equilibrium quantity is ambiguous here. All right, so let's do a couple more examples with those double shifts. So here, consider the market for Nike athletic shoes. Suppose 2 events happen simultaneously. A new Nike advertisement featuring Colin Kaepernick was generally well received by the population, and the cost of rubber, a key input for creating tennis shoes, became cheaper. What will happen in the market? So I'm going to try it using the sketch method first. So step 1 stays the same. Draw an initial equilibrium. So price, quantity. It says consider the market for Nike athletic shoes. So I'm going to write Nike here. Here's my initial demand curve. We'll call that D1. Here's my initial supply curve, S1. An initial equilibrium point, E1. Got these dashed lines, Q1. And I've got P1. So let's just take event number 1. So event number 1 is a new Nike advertisement featuring Colin Kaepernick was generally well received. Is that going to be supply or demand? So think about it for a second. All right, hopefully you realize that advertising is going to target people's tastes and preferences, which is a demand factor. So the first event is going to shift demand, and it says it went well. So this is going to mean demand's going to increase. So as you could say demand increases, or demand shifts to the right of the original. So here's D1. I know this demand curve is moving out to the right. Now again, because I have two events at the same time, I don't want to just draw one new demand curve out to the right. I want to draw a couple possibilities as dashed lines. So I'll draw a little increase in demand. There's one shift. I'll draw a big increase in demand, a big shift to the right. Maybe I'll draw one in the middle. But I know this demand curve is going out to the right. All right. Process of elimination tells me event 2 is going to have to be supply, but also here in the question it says a key input. Input is one of those factors. Input prices is one of those factors that shifts the supply curve, and the input becomes cheaper. So supply of tennis shoes is going to increase as well. It's going to increase up arrow, or it's going to shift to the right of S1. And the reason is because rubber is now cheaper, I am going to be more willing to create tennis shoes because it's cheaper for me to make them, cheaper for me to supply them. So again, just like we did with demand, we're going to draw a couple possibilities out to the right of S1. So here's a little increase, here's a really big increase, here's kind of one in the middle, but they're all shifting to the right of S1. And now we think about our 4 triangles again. Top triangle, bottom triangle, left triangle, right triangle. Hopefully you can see all the overlap of all my dashed lines is here in this right triangle of the initial equilibrium. So that means my equilibrium could be anywhere in this triangle. It could be up here, could be over here, could be here, could be here. Draw a couple possibilities if you want to. E2 could be anywhere in this triangle. So of all those points that I drew that could possibly be E2, how do those compare to Q1? Well, they're all out to the right of Q1. So that means I know for sure my equilibrium quantity increased because they're all out to the right. None of them are moving to the left. So that means my ambiguous variable here is going to be my equilibrium price. And that makes sense, right? A few of the points I drew have a higher price compared to P1. A few of the points I drew in this triangle have a lower price than P1. So that's why we say our equilibrium price here is ambiguous. Alternatively here, if I were to put my demand and supply increase together using my table, both curves increase, my price will be ambiguous and my quantity will increase. All right, one more problem like this, and then I'll let you guys try some on your own with the practice quizzes and things like that. Here we go. Consider the market for cigarettes. Suppose 2 events happen simultaneously. 2 laws were passed. One of the laws increases the tax consumers have to pay. So I got an increase in a tax on consumers to $6 per pack. And the other requires cigarette companies to research long-term impact of cigarettes on customer health. What will happen? So I will sketch this out, but first let's use this table approach to try to solve the question. So step 2, we're going to take each of these events and figure out, is it supply or is it demand that's affected and what direction? So my first event is the laws increase the tax consumers have to pay to $6 per pack. So if this tax is on consumers specifically, that is going to affect demand. So taxes are one of those things that can shift both supply or demand. So the question will always tell you, hey, I'm taxing the buyers or the consumers, or I'm taxing the sellers or the firm. Here, because I'm taxing the consumers, this is going to be a demand factor. And so since I'm increasing taxes, that's going to decrease demand, lower it, or shift it to the left of the original. So I've got a decrease in demand for the first event. Process of elimination tells me event 2 has to be supply, but you might have already figured that out because I told you that event 2 affects cigarette companies here, right? Cigarette companies have to do some research on their long-term impact of their cigarettes on customer health. So think to yourself, the cigarette companies, are they going to be happy about that and willing to supply more? Are they going to be unhappy about that and willing to supply less? Hopefully you'll realize this is a supply decrease. The supply curve is going to move to the left of the original as well. So I've had students in the past, again, try to add extra events here. They'll say, oh, well, if they're researching this, the results are going to show cigarettes are unhappy. That's going to be a decrease in demand. Please try to take the events that I give you at face value. I haven't told you what the results of the research are. Maybe the results of the research are cigarettes aren't as bad as people initially thought. That's just a hypothetical here. Everyone, I think, knows at this point that cigarettes are very bad, but just try to take the events that I give you at face value to figure out whether it's supply or demand to avoid that kind of confusion. So I know demand is decreasing, I know supply is decreasing. Go to my table here, both curves decrease. The result will be an ambiguous equilibrium price and a decrease in the equilibrium quantity. That'll be your answer using the table. If you want to sketch it out, we'll get the same answer. Let's try it. So here, let's see, my supply and demand graph. So I've got price, quantity, or market for cigarettes. I've got demand for cigarettes, D1. I've got supply of cigarettes, S1. I've got their intersection point here, E1. There's my initial equilibrium quantity, Q1, and my initial equilibrium price. Oh, I don't know why I wrote a 2 there. P1, there we go. All right, so my first event, the tax on buyers is going to decrease demand. This demand curve is moving to the left, but I don't know how far, so I'm going to draw a couple different shifts to the left. Let's see, draw a little shift to the left here, a big shift to the left here, somewhere in the middle. Doesn't have to be a beautiful straight line, as you can see, but demand is certainly moving to the left of D1. Supply, the new research the cigarette companies have to do, that is going to shift my supply curve to the left as well, a decrease. We just don't know how far, so we'll draw a couple possibilities. A little decrease to the left, a big decrease to the left, somewhere in the middle, decrease to the left. And now we can think about my 4 triangles again. Top, bottom, left, or right or left. All of the crisscrossing seems to be happening in this left triangle over here. So if we compare those, all of the left triangle shaded region, you can draw a couple points here for equilibrium if it'll help you. All of them are to the left of Q1, so that means my equilibrium quantity decreases, and my equilibrium price is going to be ambiguous. It could be higher if it's one of these points, it's higher than P1. If it's one of these points that I drew, that's going to be lower, so my equilibrium price is ambiguous. So same answer we got here. All right, so again, here's just kind of a summary of the 2 examples we did. The first question with 2 events, we wound up in the right triangle. The result will always be an increase in the equilibrium quantity, but an ambiguous effect on price. Shifts of both curves to the left, or both decreasing, will result in ambiguous price, but a definite decrease in quantity. The salmon example in the slides will lead to this top triangle where the price is definitely higher, but quantity could go either ways. And if demand were to decrease while supply increased, that would put us in this bottom triangle where price is definitely lower, but the quantity is ambiguous. So try some of the practice quizzes and practice application questions. You can sketch these. You can just use your concept guide and the tables here. If the graphs intimidate you or scare you, they are not required to solve these problems. Hopefully that helped explain things, but definitely reach out if you have any questions.